All right, let's take a look at this section. We've done a lot of congruent stuff. We had a quiz on it, right? Last time we were in here, did we have a quiz last time? Tuesday, I guess. And what were our congruence statements, I guess? We don't... Right, angle, side angle, side angle, side, 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 angle, angle, side. Remember that? There is no angle, side, side, correct? Okay. All right, so with all that said, this lesson, you could probably not even include this lesson, tell you the truth, because I think every single one of these, you could use one of those congruent statements that we did before, side angle, and that kind of thing. But all this does is kind of streamlines it, makes it a little bit shorter if you're using what kind of triangles? Right triangles, okay? So we're going to deal with right triangles. So I think I have a right triangle over here. Let's see. Yeah, there's a nice right triangle right there. So I'll grab that and put it right here. Just make it look a little different. We'll just stretch it out a little bit like this, okay? I'm going to copy and paste. So since I copied and pasted, what do you know about these two triangles? Yeah, but what if you didn't know that I copied and pasted? Could you say that they are congruent? No, you got to know some information, all right? So they are right triangles. So I'll put a little box here, put a little box here. Okay, is that enough to say that they're congruent? Just put in the box? No. But you do know that they're right triangles, okay? So what if I told you this? What if I said that this side was equal to this side? All right? Is that enough to say that they're congruent triangles? No. All right? I only know one side. And let's say they told you that this side was equal to this side. Yeah. So you could use something we've already used before, couldn't you? Yeah, you could say that they're congruent because of side, angle, side. All right? But since they're right triangles, what they do, they kind of streamline it a little bit, like I said. Just make it so it's a little bit shorter. Here's what they're going to do. First of all, what is the name? This side right here has a specific name. Do you remember what it is? Why is it the hypotenuse? Very good. That's exactly right. That's what I was looking for. It's the opposite side of the right angle. Everybody see that? So that's definitely the hypotenuse. What do we call the other two sides? If this is the hypotenuse, we could just call it a side, but we have something specific we call it. It's a leg. Did we talk about that before? I think we did. Okay, so that's a leg, and this is what? It's also a leg. All right, everybody good? So we have a theorem that says if you have two right triangles, and if you know that both legs are equal to each other, two legs from this triangle are equal to the two legs on this triangle, if you know that, and it's a right triangle, that's enough to say that these triangles are congruent to each other. So they use leg, leg, leg. This is what we say. We say leg, leg, but how do you think we write it? Just L, L, okay? We don't say LL, and I've been listening to you while you're doing the homework the other day, and everybody's like, what'd you get? Oh, I got SAS and AAS and SSS. But we don't verbalize it that way. What are we supposed to say? Side, 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 side angle, side, okay? You can write LL, but don't say LL, all right? Say leg, leg. Everybody with me on that? I mean, it's really not that big of a deal, to tell you the truth, but it's just nice if we're just using the same language, right? And we are saying it the same way. All right, enough of that. Does everybody understand that? So, I mean, technically you could say this is side, angle, side, and side, angle, side. So these triangles would be congruent. But since it's a right triangle, if you know that both legs on one triangle equal both legs on the other triangle, then you can say they're congruent. Why? Because of what? Leg, leg. Okay. All right. Then they're congruent. That's right. So what does that tell you about the hypotenuse on both of them then? Then both hypotenuse would be equal as well, right? Even though they didn't tell you that they're equal to each other. If the triangles are congruent, let's talk about that a second. I'm going to use another phrase that we've used before. We don't use it a whole lot. If we were going to do a lot of proofs on here, which again, I told you we're not really going to do a lot of proofs, hardly any at all. But what if I said, what if this was 5? What would the hypotenuse over here be equal to? It would also be equal to 5. Give me a reason why, though. So 5 equals 5. Why? I gave you a bunch of letters. Congruent's part of it. So C what? Corresponding, no, not sides, because this includes the angles and the sides. What is it? Parts. Remember that? Corresponding parts of what? Congruent triangles. What's that little dot? There we go. Corresponding parts of congruent what? Triangles are congruent to each other. Okay, that's the reason why. If you were doing proofs, that would be something that was just so second nature to you. But since we're not doing proofs, we haven't talked about that a lot. But if I showed that the triangles were congruent to each other, why are the two hypotenuses, I guess that's the plural for hypotenuse. I don't even know. I think it is. Let's look it up. I'm curious. Hypotenuse, plural. I think it's hypotenuses. Yeah, it is. It's hypotenuses. That's a weird word, isn't it? Anyway, so the hypotenuses would be equal to each other. Why? Because they're corresponding parts. Corresponding parts of congruent triangles are congruent. So what if I said that this was angle A, B, and C? This was D, E, and F. Okay? Again, I've already shown you that the triangles are congruent to each other, correct? Let's write our congruent statement. Well, how would I write this one? Now, what's the congruent statement? Okay, we could go ACB, that's fine. I usually go ABC, but that's fine to go ACB. So if I go ACB, I have to do what? DFE, right. DFE. Now check this out. So that means that all the corresponding parts have to equal each other. That means angle A must equal what? Angle D. Now they didn't tell me that angle A equals angle D at the beginning, did they? All right, they just told me these two legs were equal to these two legs, and it was a right triangle. That's enough to say that they're congruent triangles. If they're congruent triangles, all the other stuff that we didn't mention, also that stuff that matches up, right, the corresponding parts, they got to equal each other as well. So angle A equals angle what? D. Why? CPCTC, corresponding parts of congruent triangles are equal. Now, if we were going to just say this verbally instead of saying that whole thing, what you could say to me is, if I said, why are those two angles equal to each other? Why does angle A equal angle D? You could just say, because they are what? Corresponding parts, okay? And the rest, I would like kind of understand what you're saying, okay? Corresponding parts of what? Of congruent triangles, all right? You with me on that? And then, same thing, angle B must equal what? Angle E. Why does angle B equal or congruent to angle E? Why? Because they are also corresponding parts. Everybody got it? Smart. Are congruent. Yeah. I used to teach out of a book that said are equal instead of congruent. So we used to say CPCTE. Just depends what book. Okay? But this book says C. So corresponding parts of congruent triangles are congruent. Lots of C's in there. But these two C's mean the same thing, don't they? Right? They're congruent. The first one is what? What's the first C? Corresponding, right. Corresponding parts. Does that make sense? What the corresponding parts are? They're the ones that match up with each other. Everybody good? All right. I'm not going to go through all that again. Let's just talk about the other right triangle congruence And then we'll fly through these since we covered all that pretty good. Come on, grab that. Where is it? There it is. Okay, and then let's move that right there. I'm not even going to label these. We're just going to go through them. Again, this whole lesson, we're using what kind of triangles? Right triangles, all right? Now watch this. What if they told you that this one was equal to this one? So what did they tell you so far? What's equal to what? What is it? It's the hypotenuse, right? The hypotenuse on this triangle equals the hypotenuse on the other triangle. They didn't tell you that before, did they? All right? But watch this. They also tell you that one of these angles are equal. So this angle is equal to this one. Okay? That's enough to say that those two triangles are congruent to each other. Why is that like the old way? Go ahead. Did we have side angle angle? Angle angle side. Angle angle side. Because look, these two angles are next to each other. This side is not included. So it's not angle side angle, right? It's angle angle side. But since they are right triangles, instead of saying angle angle side, what do you think we could say? What is this? What is this side? Hypotenuse. What is this thing? It's an angle, right? So they call it hypotenuse angle, all right? Does that make sense? Yeah, pretty easy. I mean, technically, you could just say angle, angle, side, because right triangles, you know, they're both 90 degrees, which means they both equal each other, right? So there's two equal angles, there's another equal angle, and there's my side. So you could have called this, what is it? Angle, angle, side, but since it's a right triangle, we're going to use hypotenuse angle. Got it? I guess you could say angle hypotenuse. Aaron Hamrick, that's me, so that would be my initials. But they don't. They use hypotenuse angle. We go to that? All right. Let's do this.
Nathan Collins to office for dismissal. Nathan Collins to office for dismissal. Thank you.
All right, let's do, we got two more. All right, this time they tell you, let me click out of that. Again, they tell you these are right triangles, so I'll put the little right triangle box there. They tell you that this is equal to this. So far, what did they give you? They give you what? One pair of, well, they already told you it's right triangles, so we just make the assumption that those angles are equal. They give you a side, right? Or a what? A leg, all right? Since it's right triangle, we call it a leg. All right, so they give you a leg, and they also tell you that this is equal to this. Yes. Yes, because if it's a right triangle, this has to be a right angle. A right angle is equal to 90 degrees, correct? And then 90 degrees equals 90 degrees. Does that make sense? That's actually a step you would have to do in a proof. But again, like I said, I'm not really making you do it. But yeah, that's a good way of thinking. All right, so this angle must equal this angle if they're both right angles, because they're both 90. Okay.
I'm saying more of the line because.
But they have to show you. They got to put the little box there. Okay, if they put a box here and they didn't put a box here, you could not, because that might be like 89.999 degrees. You don't know, right? If they show the right angles, yes, and they have to, all right, because there's no way to know it's a right triangle unless they put the right angle symbol in there. Everybody got that? Right? So automatically, if they put a box here and a box here, automatically they're both right triangles. And those two angles are equal. Doesn't mean the triangles, not every two right triangles are congruent to each other. Agreed? Yeah. Well, I don't know that. They didn't tell me. No, just because you have two right angles does not mean the hypotenuse is equal to this hypotenuse. All right? Because if I had, watch. Come on. There we go. Watch. See that? What if I did that and this is a right angle? Does that mean that this hypotenuse is equal to this hypotenuse? No, it doesn't. Make sense? Okay. Okay. So, what could we call this in the old days? The old days, meaning 2 days ago. We could say angle side angle, couldn't we? All right. But what are we doing today? We're looking at it as a right triangle. So what did they give us? They gave us a what? A leg, and they gave us a what? An angle. So guess what we're going to call this? Leg angle. All right. So we call this the leg angle postulate.
The election results for 7th period has been postponed till tomorrow. The results of the elections will be announced tomorrow. Thank you.
Good. Okay, so yeah, that's it. Does everybody understand this? All right. It's almost like you didn't even need it. Would you agree? Because I could have always said, why are these triangles congruent to each other? Angle, side, angle, right? But since it's a right triangle, they figured they'd throw in a little special name for it since it's a right triangle, and that's kind of a special type of triangle. And so they said the reason these two triangles are congruent is because of what? Leg angle. Yeah, but we're starting off saying that it's a right triangle to begin with. All right, so all of these that we're doing today are all right triangles. So it's already assumed that the right angles are equal to each other. All right, so this is the stuff that they give you. I mean, yeah, they did tell you that they are right triangles. That is true. But what else beyond being a right triangle did they tell you? They told you that this was a leg, that was a leg, there's an angle, and then they're congruent to each other. So that's all you have to know. Okay, you didn't have to know that both legs were equal. You didn't have to know that the hypotenuses were equal to each other. All you have to know is one leg, one angle from one triangle to the other, and they're congruent. We got one more. Actually, yeah, this is kind of the same. So really, there's only 3 of them. But these are kind of the same. Let me grab this. Because I gave you one leg, correct? Is there only one leg? Let's try this again. No, there's another leg, isn't there? So, watch this. They could have said, there's right triangle. And let's say they gave you this leg and this leg. But what if they told you that this angle down here was equal to this angle right here? They still give you a leg and an angle, correct? That's all you needed to know. But what's like the old-fashioned way? Angle, side. Right, very good. So you could have said angle, side. If you didn't know anything about the right triangle congruence theorems, okay, you could have just said angle, side. But since you know it's a right triangle, we could also use what? Leg, angle. That's supposed to be an L. Kind of looks like an angle symbol, doesn't it? Let's make it look like an L. Leg, angle. Same reason, but on this one, it looks like angle, side, angle. On this one, it looks like angle, side. But there you go. What do you think? Pretty easy, isn't it? Yeah. That was pretty short, wasn't it? Probably could have made it a little shorter, but that's all right. All right, so what's your homework? Your homework is section 4.6. Yep. Pages 188, 189, and 1 to 14. I'm glad to see that somebody's using my lesson plans, because in the other class, especially in my CP classes, they ask me stuff all the time. I mean, they're absent a day, and they're like, what'd we do? I'm like, did you get a lesson plan? Yeah. I'm like, well, look at your lesson plan. You know, why would you ask me? I don't understand. I still tell them, but I also get on their case about them. They should have their lesson plan in front of them. Plus, it's on RenWeb too, isn't it? Does anybody ever check the RenWeb to see what your assignments are? You can do it. I always put it on there every Sunday night. Okay, it's on there. And that's fine. If you want to look at the paper, that's good. But what if you didn't have the paper? You could always go to RenWeb and look. And after I teach the lesson, you could always go to the YouTube and look too, because I always put it on there. All right, enough of that. Let's get working. Let's try to get this done before class is over so you don't have any homework tonight, okay?